Hey everybody, we're looking at video number 2. Hopefully you had no issues going through the review of circles and the vocabulary and things like that. And now we're getting ready to run head on into the area of a circle. All right, here comes the fun stuff. Now we're going to actually find the area of this circle. We've been looking at this for a while now, and now it's time to find the area. When we were together in class the last time, I asked you guys to figure out how many squares did you think it took to cover up the inside part of this circle? And we had a lot of good guesses. Some people just counted the full squares. Some people said, well, I noticed that this piece right here and it would finish this square over here. So those two would be putting together. So some people were combining squares. Some people were just looking at the full squares. Some people counted everything no matter what. That would be a very tricky way to do this, finding the area of a circle. So instead what we're going to do, this is one of the few formulas that we use in 6th grade math. There are a couple different parts to it. It says A equals pi r squared. Now that is an exponent. That is not a 2. That is an exponent. A stands for area. The pi symbol. We're going to use 3.14 instead of that pi symbol in a second. What do you think r stands for? That's right. That's the radius. And then we're going to square the radius. Now, a formula is a lot like a recipe. If you're trying to cook something, it's the recipe of the math problem. We're going to take some ingredients and we're going to plug them in the right spot, and then we're going to cook it up and hopefully something delicious comes out. So when we do this, we're going to start plugging in our values instead of the different symbols and variables that we're using. So A is area, that's what we're trying to find. Now we're going to go ahead and instead of pi, we're going to plug in 3.14. And notice I put that inside of parentheses. The radius of this particular circle is 5 units. And if we count those 5, we can see it goes 1, 2, 3, 4, 5 units. That's our radius for this particular circle. So that squared then goes along with the radius. So when we plug all those into our formula, we have 3.14 in parentheses. That kind of holds everything together. And when we have a number right against the parentheses, do you remember what operation we do? That's right, we're going to multiply it times the 5 squared. Now, before we do that, we have to go back. Remember our beautiful old Aunt Sally? She was such a beautiful old lady. She says that we have to do what's in parentheses first, and I don't see anything really to do. It's just the number, 3.14. But then after our parentheses, we have to do our exponents, and here we have 5 squared. So we're going to have to figure out what 5 squared is, and that is a perfect square. And in order to do that, we're going to take 5 times 5. Not 5 times 2. Get that out of your head. 5 times 5, and that equals 25. So that's what our next set of numbers is going to be for our formula. So 3.14, nothing happened to it, but the 5 squared is going to turn into 25. Now, again, when we see a number right beside the parentheses with no other symbols in between, we know that we're going to be multiplying. So in our calculators, yes, you can do a calculator with all this stuff. You don't have to do mental math. We're going to take 3.14 times 25. Now, if I want to take a guess, if I take 25 times 3, see if I count quarters, that would be 25, 50, 75. I bet my answer is going to be somewhere in the neighborhood of 75. So I'm going to go ahead and plug that in my calculator, and sure enough, look at that. Our area equals 78.5 units squared. And that's pretty close to what our guess was. We said it was going to be in the neighborhood of 75. And I think some of you in class even had 78. You got really, really close. Oh, there's one last thing. Whenever we do this, don't forget, always circle your answer. An area always has square units. So square inches, square centimeters, square miles, whatever the case may be, we always square our units. Finding the area of a circle is pretty important in the real world. For example, look at this awesome pool. Man, cannonball right in the middle. And we want to cover this pool to take care of it when the weather starts getting too cold. So finding the area that we would have to cover for this circular pool would be a situation where we need to use our formula. So if we go to the store and we gotta talk to the salesman and say, hey, we need a cover for our brand new circular pool, one of the things we need to do is figure out that area. So again, there's our formula at the top. Area equals pi times the radius squared. Now, if I take a look at that picture, I'm missing a very key ingredient to this math recipe. What do we need in order to find the area? We know what pi is. Pi is never going to change. It's always going to be 3.14. Doesn't matter what size circle, how big or small, it's always going to be 3.14. So the only piece of information missing is the radius. So I've gone ahead and included that. Let's say the radius of this pool is 8 feet. Okay. Oh, by the way, that would make the diameter how long? That's right, 16 feet. So that's a pretty big pool. So the radius of this is 8 feet. So what we're going to go ahead and do is set up our formula and start plugging in numbers. So area is going to equal pi, there's our 3.14 in parentheses, times the radius squared. So again, if we look back down to the information we were given, the radius is 8 feet. So we put our 8 in there and we square that number. Our next step is to go ahead and take care of our exponent because there's nothing going on in our parentheses except for the pi number. So 8 squared means 8 times 8. 8 times 8 is 64, not 16. Do we ever multiply the base number times the exponent? No. So 8 times 8 is 64. Then we're going to go ahead and plug those numbers into our calculator, and we find that the area equals 200.96 square feet. Now, if you notice, I didn't write an exponent with my feet this time. This time, I wrote SQ feet. That stands for square feet. Sometimes we'll write feet squared, but this time we just did square feet. So, oh, there's one thing missing. I can't remember. Oh, that's right. Always circle your final answer. So hopefully you've gotten the idea that finding the area of a circle isn't too tough. You only need 2 ingredients, and one of those ingredients we always know, pi, 3.14. In fact, if I gave you a picture of a table just like this and asked what is the area of the circular top of the table, and look, there's a number already on there. It says 6 feet. Could you tell me the diameter? Sure. The diameter is 6 feet. That's going all the way across the table. What about the radius? Could you already tell me the radius of that circle? If you can't remember, think. Radius is half the diameter. If I know the diameter is 6 feet, the radius is half of that. So the radius must be how much? Hopefully you said 3 feet because that would be correct. So we already know pi, 3.14. We already know the diameter of this table, 6 feet. That was given to us. We can figure out the radius by cutting diameter in half and getting 3 feet. There's a ton you already know. In another video we're going to do a little later, I'll teach you how to find the circumference, how far around that table, but that's not for right now. Next, we're going to figure out the area. Since you have all the ingredients you need, let's go ahead and plug them in. there's our formula. Area equals pi r squared. It's very important that you don't say pi r2, because that would not be correct. It's pi r squared. That's why exponents are so very important. So let's go ahead and start plugging those into our formula. So area equals 3.14. That's our pi. Our radius, we said, was 3 feet. We're going to square that. There we can see the square exponent already in place. Next step, let's go ahead and do the math on squaring those 3 feet of the radius. Well, 3 times 3 is 9, not 6. I keep saying that because that's going to be a big mistake that we're going to end up making. And I promise you, the test people are ready for it. They know that you guys want to just take 3 times 2. Don't let them trick you. 3 squared is 3 times 3, which is 9. Now we go ahead and plug that into our calculator. I'm going to predict that our area is somewhere around 27 square feet, because 9 times 3 is 27. So I bet it's somewhere close. Hey, check it out. Area of this circular tabletop is 28.26 square feet. I'm missing something. What did I forget? Oh, that's right. Always circle your final answer. That's pretty much all there is to finding the area of a circle, guys. We need 2 parts. We need pi, which we always know is 3.14, and we need the radius. So what I've gone ahead and done is given you 2 problems to work on. First, it says, what is the area of the Ferris wheel? That's a Ferris wheel like you'd see at the 5-county fair or any amusement park. And there it's given us, I guess that's the diameter going all the way across from one side of the circle to the other. And it says the diameter is 52 meters. So just like the previous problem, go ahead and find your diameter. It was 52 meters. Figure out your radius, cut your diameter in half, and then plug those into your formula. What was it again? Area equals pi r squared. Again, rewind the video and go back and write it down somewhere so you don't forget it. The second problem, a little bit trickier because here we're talking about the area of the orange slice, and it says the diameter is 3 inches. Ooh, what would the radius be if it were a diameter of 3 inches? That's tricky. Guys, email me your answers, cmotter@cucps.k12.va.us once you have them.